Hello friends, can you see that I've taken this cycle's part over here, quite old and rusted, never mind, it has got a heavy rim, and I'm going to create an angular momentum vector towards it while after rotating this one. But you just see one thing, that when I'm leaving this thing, this is falling down. We must be knowing that there is no vector over here, angular momentum vector, to stabilize it. Once if I rotate it, by some action, I will rotate it, you will find that this will stabilize and will not tend to fall down as predicted. There are many YouTube videos also acting on it. When you will find one thing, that this will obey the torque acting on it. How? It will have the formula tau is equal to r cross f. The mg will be acting downward, just what like this. And if I take my four fingers of the right hand, and if I try and rotate it, then r cross f, the radius will be towards this side, and r cross f will be the mg downward. So torque will be acting this way if the radius is outward. Now what is going to happen over here, that r's direction will be decided by the angular momentum vector. R is in the same direction as the angular momentum vector, which will be in the anti-clockwise direction. Suppose the angular momentum vector is in the anti-clockwise direction, then the r will be pointing outwards. Why? Because of this right hand screw rule. If I try and move this thing like this, you will find that the rotation, the anti-clockwise rotation, will cause the vector pointing outward. Anyways, let's see that if the r is like this, you will find the thumb pointing over here, the torque is acting on the. If the rotation is the opposite direction, then obviously torque will be in the opposite direction over there. Let's see. I pause the video for the rotation once over here. Okay, so I'm back over here. You can see that once it has been rotated, this is moving in this direction. Why exactly? You will find that the anti-clockwise rotation is pointing over here. This angular momentum vector is acting outward. So the torque is moving, so that's the following: r cross f. So r is outside because of the angular momentum, and f is downward. And you can see this is slowing down, and as it slows down, the angular momentum vector is falling, and so this is something happening. I again pause the video for rotation. Well, I am back over here. Can you see one thing, that now this is moving like this, in this direction, in opposite manner? What is the reason? That now this wheel is moving in the clockwise direction, confronting you. So the angular momentum is backward. So r cross f will be in this direction as I am rotating my fingers, and the torque is acting in the opposite manner. So it depends upon tau is equal to r cross f over here, and so that's why. And see the stability of this angular momentum, so that it falls down. And I try and do like this, then also it is not even falling right over here. The angular momentum vector is, so this is the principle on which the cycle runs, the motorbike runs over here. That's the fundamental of it, and the bikes and the cycle never falls over here. So it with a great difficulty. Once again I'll try and rotate it off, and I pause the video over here. Okay, well, welcome back. Can you see that now I've rotated it anti-clockwise, in fact, right, from facing you, and so the torque is acting over here. Now can you see the stability of this? It's not even falling. I am trying to so that it turns over here, and you'll find that something is happening. Can you see one thing, that if I hold it, it's moving in this direction. When I rotate, and moving in this direction. In fact, just see over here that automatically when I turn the radius, it's moving over here in this direction. So I'm not turning it, it's turning of its own. So this is the fundamental on which the angular momentum and the radius vector runs over here. Thank you so much.